Here we go. Pi over 2. Let's go. Pi over 2. What do you got? Pi over 2. Same. Just yell it out here. I don't have time to do the numbers. 90. Pi over 3. Oh, boy. We're in trouble. Pi over 3. 60. Sorry, I didn't go in number order. Pi over 4. Pi over 6. Pi. 3 pi over 2. And 2 pi. Okay, I'm going to ask you to know those from now on. Okay, when we say pi over 4, we're going to know it's 45. And I don't expect it to be greatness today, but as we start using these over and over and over again, you will start knowing these off the top of your head without having to memorize anything. Okay, here is exactly I'll show you the reason in a second why it's nice to know all these off the top of your head. All right, so you guys have these graphs here on your packet, first page of today's notes. I'm not going to do all of them. All right, I'm just going to do the first one up there on the top left. Usually, if I had you guys fill these in degrees, you would put 0. What would you put here? 90. You would put 180 and 270. All right, can we do that in radians now? Can we, instead of putting degrees there, can we put radians? So 0, this was 90. What did we just say 90 was in radians? Pi over 2. This is usually 180, but now we're going to put pi. And instead of 270, we'll put 3 pi over 2. All right, everybody good there? Okay, because now we're going to start working exclusively in radians. And I do not have time, you do not have time to go convert again. Okay, degrees, back to radians, back to degrees, and so on. All right, so now we're going to start working exclusively in radians. Questions so far? Okay, I'm going to do a little something different with your notes today. I'm going to go end to beginning. Okay, so you should have questions 1, 2, and 3 in your notes right now. If you turn to the next page, I'm going to start with number 3. Okay, I'm going to start with number 3. I just think, and the reason is I just think it's easiest. I think I put the harder stuff first, and I want to do that last. Okay, so for number 3, state the quadrant of the following and find the reference angle. No calculator, please. That's a little bit of a lie, but what I mean is don't go to your formula sheet and multiply by 180 over pi anymore. We don't have time for that, and we don't need to do it anymore. Ready for this trick? 7 pi over 6. Ready? Pi over 6. We just found out was what? That's one we're going to know off the top of our heads by tomorrow. Pi over 6 is? Look back if you have to. Look back, please. We're just throwing out numbers. Pi over 6 is the same as what? 30. So all I have, watch, ready? If that's 30, all I have to do is 30 times 7. Go ahead, 30 times 7. We're done. It's 210. All right, 210. What quadrant is 210 in? Quadrant 3. And it also says find the reference angle. All right, we may need to just draw that out so we can see what it looks like. So I'm in quadrant 3. There's 210. And we all remember where the reference angle is, right? Not what it is right now, but at least where it is, right here. Can you find how many degrees are in that reference angle? That's 210 degrees. Remember, from here to here is 210. I'm looking for this angle right there. How many degrees, are in that angle? Let me know what it is. If you need help finding it, let me know. 12? 30 degrees. All right, it's 30 degrees. But we're going to go exclusively in radians. So what are you going to tell me 30 degrees is in radians? Look back if you need to. I cannot give it to you. The only way we're going to learn it is if we go back and forth looking at what it was. What was 30 degrees in radians? Pi over 6. So we're going to say the reference angle, theta with the little r below, which tells me it's the reference angle, is pi over 6. And you're going to notice a pattern here by the time we're done with the next two. Well, you stop. There's no pattern yet. We've only done one. Negative 2 pi over 3. Ready? Pi over 3. Pi over 3. 60 times 2. 60 times 2. Okay, we don't need to convert anymore, do we? Do we need the reference sheet anymore? Well, we might need it if we don't know that, but not a lot of them will have that. So again, let me go slower. Pi over 3, what did we just learn? Pi over 3 is what? 60 times 2. 60 times 2? Okay, so that's equal to negative 120. What quadrant am I in if it's negative 120? Make sure you go in the right direction. 13, negative 120. Third quadrant. You're going clockwise, remember. Third quadrant. What would be my reference angle now? What would be my reference angle? Again, you need to see a drawing of it. Here's negative 120 going that way. What's your reference angle? Right there. Remember, reference angles are always positive and less than 90. So don't give me a negative answer. Don't give me an answer bigger than 90. What is my reference angle? What does that angle measure right there if that was 120? Here we go. Let's hear from 1. What do you got, Olivia? 60. Perfect, but we're going in radians. Pi over 3. So the reference angle is pi over 3. Oh, boy. I don't know if anybody sees anything yet between my original angle and what the reference angle is going to be. One more. This one you may need the calculator for, I agree here. But pi over 4, 45 times 11. Go ahead, 45 times 11. That's really what you should only use your calculator for. 495. All right, got to go around more than once with the pinwheel, right? What quadrant is 495 in? What quadrant would 495 be in? So make it smaller if you need to. We know how to make it smaller. 495. Quadrant, when you're ready. 14, quadrant. 495. So I go all the way around. I'm at 360, right? Okay. I go another 90. I should be at 450. Okay, so I'm not at 495 yet. First of all, how can I make this smaller? So I don't have to keep going all the way around. Okay, subtract 360. Go ahead. What do you end up with? Okay, so where's 135? It'll be in the same quadrant as 495. Second quadrant. And reference angle. I don't know if anybody has seen the pattern here up yet. If not, we can just find it our old way, which is by graphing it in the second quadrant. What is that reference angle there? And remember, that was 135 from here to here. 135. So what must have been my reference angle? When you're ready, 17. 18. 45 degrees. Which is what in radians? Oh, so anybody just want to tell me here how I can get the reference angle pretty quick, Brett? Sure. Okay, I'm not, at this point, I'm not concerned. I'm not concerned. Okay, but okay. Actually, it's not. Does it in my directions? Does it say graph it? Does it say? I don't see the word GRA. You know those letters GRA PH next to each other. They're not. Yeah. So yeah, I guess I win once again. All right. Lily, you see anything? Yeah. Look, 7 pi over 6, and that was my reference angle. -2 pi over 3. So right now we can find the reference angles pretty quickly because it's just whatever is attached here. 11 pi over 4. Okay, so it'll go pretty quick now. Everyone all right using these now to get to the degrees more quickly than going to your reference sheet, crossing out pi's, multiplying in your calculator. Everyone good now? All right, and again, please keep looking back and forth until you are comfortable doing these all by yourself. All right, let's keep going backwards. Okay, here we go. Now maybe I'll get particular on where my arrows are, my terminal side. All right, here we go. Let's see if we learned anything. Sketch an angle of, we'll do the first one here on to the left, 5 pi over 6. Ready? Pi over 6. 30. 30 times 5. 100 and? Okay, we can graph that now. Closer to 180 or 90? Want to make sure I get it right because it does say sketch now. Closer to 180, yep. And we don't have to, hopefully we're not going to take time to figure out what the reference angle is. You can just look at the actual angle now. What's going to be your reference angle? If the actual angle is 5 pi over 6. Pi over 6, yep. Yep. You could just write reference angle because they don't tell me what Greek symbol the angle's equal to, but so you can just write the word reference out if you want. All right, going to you guys now. Here we go. 6 pi over 4. 45. It's negative pi 45. What quadrant? Fourth quadrant. Yep. Oh, where's this going to be, kids? Closer to 0 or 90? Directly in the middle, yeah. As close as you can come to it. Am I going too fast here? Because this is a nice, I don't like to use the word trick because it's not, it's math. All right, we're doing math here. It's not a trick at all. What's your reference angle? It was negative pi. I don't want to put negative though because reference angles can't be negative. So instead I'll put positive pi over 4. $17. Oh, you're slow. I was already looking at you. You're slow. 4. 4 pi over 3. Ready? Pi over 3. 60 times 4. 240. Look how quick we're going. What quadrant's 240 in, Sarah? That took 15 seconds. Instead of now what? Looking at my formula sheet. What do I multiply by? All right. And look, these are only good. You know, if I do something like pi over 10, yeah, we got to go back to the formula sheet. These are only good for the ones I given you in the beginning of class. So I got third quadrant, you said, for 240. That's closer to 270. Okay. And in radians, what's my reference angle? In radians. 11, reference angle? Pi over 3. We liking this? Okay, well, not yet you won't after I get to the first problem. And finally, 9 pi over 4. 3 pi over 4. Yeah, this is one we haven't used since the beginning of class, so it's fine. 45 times 9. Keep going, Ben. Yep. And then I'm going to ask you what quadrant's in. 405. What quadrant am I in? First. Yep. Closer to... No, closer to 0. Right in the middle? Okay. What am I going to need for this when I do my rotation arrow? Because if I just go from here to here, that's not 400 plus degrees. So I need to do the old pinwheel, right? So going around and stopping. Don't care that I went around more than once. Don't care. Reference angle. 6. Done. Pi over 4. 45 degrees was the reference angle. There you go. Take a quick breath here because it's going to get even more intense on number 1. Anything you want to ask about? I want to make sure I didn't go too fast because I don't want to lose you on this last part. Here's what I'm going to do to finish off class. Now what I'm going to do is I'll give you the reference angle and the quadrant we're in. You give me the original angle now. Okay, so I will give you the reference angle and the quadrant we're in, what must have been the original angle I was working with. All right, so here we go. All right, so I have a reference angle of pi over 6, which in our mind we're thinking what as far as degrees? 30 degrees. And I'm in quadrant 2. What was the original angle I started with? All right, and it has to be in, find the angle in radians, then write the angle in degrees. So we're going to need both. Okay, so I'd like to get a diagram done of this. What's this angle look like? All right, instead of trying to compute numbers in my head, I know I'm in what quadrant? Second quadrant. So get off my back. I have no idea what the original angle is going to be, so I'm just going to put an arrow in quadrant 2. I don't care what it's closer to. Everybody good? Everyone see what the reference angle is? The reference angle is pi over 6, also known as what to us? Pi over 6. Pi over 6? 30. So that's 30 degrees right there. Done. 30 degrees. So I need to know, here's what I'm looking for. What must have been my original angle in quadrant 2? So yeah, I'm asking you to go backwards here. So what must have been theta? And I know it says in radians, but it also says in degrees, and we can convert to radians. So what must have been, you can give me degrees first. Here you go. Nope. 2. Come on there, superstar. You want to battle with the big boys? Here we go. What was my original angle in quadrant 2? That angle's 30.
Yeah.
And if I go all the way around, it's 180.
Yeah.
Okay, it's 150 degrees. Got it. Can we convert quickly without having to go to our reference sheet?
Yes.
What was your reference angle? No. In radians, what was our reference angle? So we know this has to do something with pi over 6, right? What are?
Is it 150 divided by?
No, don't. Let me teach. Thank you. Let me teach. 150, right? What's pi over 6 again? That's 30 degrees. 30 times what gives you 150? 30 times what? Done. Do whatever you're going to do, but I got there pretty quick myself, Art. No, because I cut you off, so we didn't say the same thing.
We're just
Okay.
like on a connection.
We're never going to be connected, Art. No matter how hard you try, never. We're never going to look the same, be connected the same, never. Don't even think about going around the hallway and saying we're boys either, all right? Because that'll never happen. No, absolutely not. It's only what, week 8? No. You got a lot more to go, bud. A lot more to go.
What if I tell people to stop in the handicap doors?
Great. It's only when I see it I get aggravated. All right.
Just knowing that I'm out there, trying to get rid of these pet peeves.
No, I'm good. Thanks. Spend your time elsewhere. Don't start chiming in either. You got me up front. Pi over 6, we're in quadrant 4. Here we go. Pi over 6, quadrant 4. What's pi over 6? 30, okay. So that angle's 30 degrees in quadrant 4. What must have been my original angle? Remember, you're in quadrant 4. So you have to at least give me an angle between 270 and 360. Have to. All right, because that's what quadrant 4 angles are, between 270 and 360. I know that's 30, so 3. What do you got for me, Ben? What's that angle? 11. Oh, no, easy, boss. I just want the degree measure first. Don't start freaking everybody out. 30 degree. I know that's 30, yes. What's the original angle? 330, yep. Everyone's all right with that? Now I have to turn it into radians. So I think to myself, okay, that was 30, so I know it's going to be pi over 6. 30 times what gives me 330? And if you have to use your calculator for that, I get it. But at least we're not using the formula sheet here. So, yep, so 30 times 11. All good. Anything here? You want to try the next one on your own? You're in quadrant 3 now. Pi over 3. What's that in degrees? Pi over 3. 60 degrees, yep. So in degrees, what are you finding the angle in quadrant 3 to be? In degrees. I know I got a 60-degree reference angle. In degrees, 9.
Wait, you want it just in degrees?
In degrees, yep. I'll take care of the radians in a second.
For the reference angle or just like...
Well, I know the reference angle already.
Oh, yeah.
So what's my actual angle in quadrant 3?
So it's gonna be 240.
240. Yep. So to find the radians, I say, my reference angle was pi over 3. Now I just have to figure out what do I multiply 60 by to get 240. So what was your radian answer here? 10? 4 pi over 3, yep. Any questions there? Okay, and then now let's go to quadrant 2. We've been there, but pi over 4? 45, yep, 45. In degrees, did you find the angle in quadrant 2 yet? 1, Olivia, did you find that angle?
In degrees,
Yep, in degrees only.
135.
Got it. Perfect. Nice job. 135. I know it's going to be in radians, something with pi over 4. I just got to figure out what do I multiply 45 by to get 135. So in radians, what are we looking at? 15? 3 pi over 4. It's not bad. The only time we're not going to be able to do this is, I give you something like this, 3 pi over 10. Right? We don't know what pi over 10 is, so what can we still always revert back to if we need to? How can you convert that into degrees? Go back to where? Reference sheet. And multiply what you got to multiply by like we've been doing the last 4 days. Okay? Everyone good? All right. The assignment is just more of these problems. All right, so let's get going. I'll walk around, help you out if you need it. You can get your Chromebook out and look up the answers as you're doing them. They're all posted